All right, welcome everyone. So let's continue working with functions in R, customizing our own functions. Here, what I want to do is create a function in question 3, which is called myDensity, which is going to return the probability density of a normal random variable, which has mean, mu, and standard deviation sigma for each value in some vector x. And so just recall that for a density function for a normal random variable follows what's called the Gaussian function. Actually, you might not have seen this before. So the Gaussian, this is actually the formula that we can use to plot the curve that we had up here. So this is a normal distribution. If you've ever wondered what's like the formula that we use to plot these curves, it's called the Gaussian, and it has this magical formula here. Looks like this. Just going to zoom in on it. And like, in case you're wondering, like this is one of my favorite mathematical formulas in all of math. Um, it has like the two most famous transcendental numbers, irrational numbers, e and pi in it. And it's like the most fundamental thing in all of statistics, right? So that you have this normal distribution, which is like the foundational thing in statistics. And who would have thunk that that involves e and pi? Who knew? Crazy. Total side topic. But anyway, that's the Gaussian formula. So the task here is we would like to define a function to calculate this in R. And we're going to call this myDensity. Okay, so there is the formula. I'm going to actually zoom out so I can see the formula and I can code this at the same time. So I'm going to begin this with function. And now we're going to have three arguments, right? We're going to have an input, which is going to be a vector x. We're going to have a parameter mu, which is going to be the mean of our normal distribution. And we're going to also need to input another argument, sigma, which is going to be the standard deviation of the normal distribution. So we need to first tell what are going to be the three things a user is going to need to tell us in order to calculate the value of the density function. So they would need to tell us, what are you plugging in for x? What are you plugging in for mu? What are you plugging in for sigma? And once someone tells us this is the value of x, mu, and sigma, then we would be able to evaluate the right side of this equation and get an output. So those are the three inputs. Then we enter our curly braces. Inside of these curly braces, we're going to input all of the code that is going to be executed to evaluate that formula. And this formula is busy. There's a lot going on. So we certainly could enter this all in at once. I'm going to break this up into smaller pieces just to make this more digestible. So let me just start with the fraction out in front. So let me first just say, we first have this multiple out in front, and I'm just going to say that that is 1 divided by, let me be even more careful. Let me just call it like this. I'm going to say we have this multiplier out in front. I'm going to call this denom. And in the denominator, I've got sigma times, and then the square root of 2 times pi. Okay, and so one thing to keep in mind here is the number pi we can get in R by typing the combination pi. That's a reserved for the number pi in R. So you can see that is kind of got this special pi. So all I've entered so far is the denominator of this leading multiplier in front. So anytime I multiply things, if I want to have 2 pi, just be really careful. I can't just type 2 pi. I need to be really explicit and literal and say I am multiplying 2 times pi. So I need to put that multiplication symbol there or else R won't know. And to take the square root, I can use the square root function. So this is sigma times the square root of 2 times pi. Okay, next I'm going to worry about the stuff that's in the power of the exponential term. So on top, I've got x minus mu, and that is being raised to the second power. And so in R, we can actually raise to the second power using the caret. In some other languages like Python, you can't do that. In Python, you need to do like 2 asterisks. That works in R. I can raise to a power with 2 asterisks, or I can raise to a power with the caret. So I'll just use the raise to the power with the caret here. On the bottom of that fraction, I have 2. And again, I need to be really explicit here. I can't just type 2 sigma squared because it doesn't know. It just treats that all as like one string of letters. And so if I want to multiply the 2 times the sigma squared, I need to explicitly say 2 times the sigma squared. I need to put that multiplication there. And to help with the readability of these mathematical operations, I'll just say it's helpful to put spaces in. The spaces are cosmetic. So R doesn't read the spaces in a mathematical expression. They don't they don't do anything mathematically. It just helps add some white space so that it's easier for us possibly to read the mathematical expression. So I think putting the space between the asterisk and the 2 and the asterisk and the sigma squared makes it a little bit easier to read that as 2 times sigma squared. So I do encourage you to like put spaces between the operators since x minus mu is a little bit easier to read when I put the spaces between it is all. Okay, so far I've entered the denominator of this multiplier that's out in front. I've entered the top of the fraction in the power of the exponent. I've entered the bottom of the fraction in the power of the exponent. And now I think I'm ready to combine everything together to calculate the output of this density. So I would take 1 over this denominator. So that's 1 over sigma times the square root of 2 pi. Then I'm going to multiply that by, and remember, e raised to the power, in R we have this exponentiation function exp. Then I have minus top divided by bottom. And these spaces don't do anything. So it's going to read this as minus 1 times top divided by bottom. And that looks good. And then we want to see the output printed to the screen. And I think this defines our my density function. So it's going to take an input of vectors. So it's going to apply just like we saw with like the log functions at the start of this worksheet. It's going to apply this function to a vector. So it's going to apply this function to each value in the vector separately. And it needs to know what is the mean and the standard deviation for that normal distribution in order to calculate that PDF function. So now we've just defined this function, but we don't have any output to look at here because the output was the creation of this function. And in question 4, we're going to check to see how we did.